Why is that?
It's just easier.
It's easier, but why is that they don't go to infinity?
And also, I like how they're opposites of each other.
Why can they not go to infinity?
Because it's the exact because it only goes up to it. So like the longer the hypotenuse gets, then the shorter one angle gets. So they're always directly related to each other.
So it goes back to, you're close. It goes back to what's always the longest side.
Hypotenuse.
And therefore, well, you may or may not know this. That's why. So therefore, you can only get a fraction that is between
0 and 1.
That's it.
Hi.
Now, there's this classic story about how the first Europeans had contact with Polynesians, that things would go missing. And so the Europeans would say, hey, my stuff was stolen. And what reality was that in their society, it was okay to borrow these things.
Oh, borrow. Okay.
We would consider borrowing permanently stealing, though, but there is a class somewhere. Let's see. What do I want to share with Ben? I want to share which screen? His screen.
It's not that hard. I figured out a platform to work on. So we only have ancient lit, science, and oh yeah, and also worksheet from period 2. But that worksheet's not hard. You didn't finish. Wait, you have ancient lit? Yeah. What is your ancient lit? Finish question 6.
Period 2 did not get 9 or 10. How did you guys do with 9 and 10?
I did it.
I did a bunch.
9 and 10
Yeah.
weren't that much. I probably did it wrong. Oh yeah. I tried to figure those ones out. 9, 10. Yeah. 9 and 10.
You will be shocked when I show you how easy it is.
Oh wait, no, now I realize it.
Yeah, 9 and 10 was easy.
Oh, I have to change. Do I have to change my mode today?
Yes, make sure your mode is in degrees.
Oh, I thought like special radius.
Well, if you ever reset your calculator, it will go back to radians.
9 and 10 are easy. They all had n in it. You could just take n out of all.
Well, just chill, cool your jets. Yes, you're correct, but they don't realize that. Number 9, you got a right triangle. They give you all 3 sides, n, 2n, and n root 5. So it kind of looks like a special right triangle. We had an n, we had a 2a or a, 2a, and a root. Well, it wasn't 5. It was, and those are all in the wrong spots anyway. So we only know one trig functionality, and that trig ratio is, and that is equal to the tangent of any angle is equal to
the opposite.
And I'm just going to put a for the sake of it. Opposite over adjacent, ADJ. Okay. Well, we are told that, and there's got one more thing on this. Y is right here. So we're asked to find the tangent of angle Y. So we need opposite over adjacent. That would give us
N over QN.
Opposite over adjacent. And if you look at this, is what Jack was saying. Look at it.
Oh, the N.
And you're left with 1/2. Now remember, we're trying to get y by itself. In order to get y by itself, you do inverse tangent. So when you're solving for an angle, it's always inverse. When you're solving for a side, it's regular, whatever trig ratio. So we need to actually do the inverse tangent of 1/2 or 0.5, whatever. So you just do inverse tan of 0.5, and you will get the answer.
You messed up my calculator. Why do you keep on doing this to me, Jack? I set the things so
All right.
that it would.
Anything else? Yeah.
I have a lot. 11, 12, 14, and z of 8.
All right.
I'm sorry, that is a lot.
11 and 12 are really close to each other. They're not that much different, right? So pick one, 11 or 12.
11.
All right, let's do 11. All right, so 11, the triangle's upside down, so to speak. Looks like this. You're told that the hypotenuse is root 34. We did this was the last question I believe we did in class yesterday. And then this side is 3, and this side is y. And you're asked to find y. That's y degrees. All right, so we need, for tangent of y, we need opposite over adjacent. What's the opposite?
3.
And what's the problem is that the adjacent isn't listed. So if you remember, wait, you came in and asked this question, I thought.
No, I
Yes?
asked you the other one.
Okay.
First degree.
Hey, so this is one of those one just combines Pythagorean theorem. I know two sides. I have to get the third side, so I'm going to use Pythagorean theorem to find out what that side is and put it right there.
Oh,
So 3 squared is,
9.
this is the hypotenuse, so a squared plus b squared, 9, equals,
C squared.
which in this case would be,
34.
so 34 minus 9 is
60, 25.
square root 25.
5.
How do we find y? Inverse tan of 3 over 5. The other one is done similarly, 12. What was your other one?
14.
I know what I can do.
14.
2.
Looks like we got an isosceles triangle. You are told that, well, this is clearly an altitude. You're told that the altitude is 200. And this angle here is 35. What are we asked to find?
W and Z.
W and Z. So W is this piece, but hey, it's an isosceles triangle with an altitude. So if this is W,
On the other side.
the other side, it's only for isosceles triangle. Not true for any other triangle with an altitude. And that's got to be W. And then
just do angles.
Z is the whole darn thing. Okay, so we're going to find W, right? So tan
35.
is equal to,
200 over W.
now if you know the pattern, you can do the pattern. If not, you got to do some algebra. We do the algebra, both sides times W. So we get W tan 35 is equal to 200. Divide both sides by tan 35. And that will give me W. And then double W gives you Z. Double W. Isn't that what W is? Double U?
That's true.
Double
So it's
U.
quadruple U.
Did you ever realize that?
Yeah.
That the letter is actually
Yeah.
double U?
Except a lot of people read it as a double C.
McKinley, did you know that?
Yes.
I never knew that. I mean, it was later in life that it finally struck me. I was like, wait, double U. I never realized it. All right.
Some of them actually have real names that make sense.
I doesn't look like an I. A doesn't. Is there any other letter that looks like what it sounds? You can't say T looks like a T because we say it looks like a T because that's the letter T.
Sure. Dinosaurs.
O is kind of like your mouth makes an O when you say O.
Yeah, but that doesn't mean it.
I know.
But,
I might be
I
needed.
had a question on 17 and 18.
Was that it? After,
Oh, I also had 18 for Z.
all right, 18 looks fun. All right, let's see. Yes, I'm bored and I want to do some math. And if it's geometry, I am always happy to do geometry. If it's algebra, I may not be happy. All right, so we have a right angle, and then is it a median? No, we don't know. It could be. We don't know. Actually, no, we see the angle, so it's not a median. We're told this is Z, this is W. It's hard to understand where that 42 goes to, but we have to make the assumption that since that's obtuse, right, as the way it's drawn, it has to be obtuse, then the other one's 42, but it's unclear. I mean, they put the 42 like right exactly where I put it.
Yeah, that's true.
And then the other side, which has to be acute, is what is it, 60? Okay. So we got a 30, 60, 90 triangle there.
It doesn't have to be acute. It has to be right.
No. This is right. This can't be right. It has to be acute.
So the other
No, it's wrong.
No, that's correct. What he's saying is correct.
Ben, you don't see
No.
what I have.
Oh, okay.
Okay. Because remember, if you got a right angle, then the other two have to be acute. All right. And the other side's 900. I don't know who that is.
Wait.
Comment?
I was just.
All right.
No.
Okay. So we got to find those two. Well, geez. Well, one thing we could do,
You can find out W.
we only know tangent, right? We only know tangent.
I use sine on one of them.
Well, you can, that's cheating, but not really. All right. You can look at the whole thing, and I guess you could say something like tan 42 is equal to the opposite, which is 900, over the adjacent, which is z plus w. Well, that didn't help much, right? You can say that, though.
Well, you could say.
I know. Okay, so that didn't work. So let's go to the other, because remember, the tangent only works with right angles. So let's go to the smaller one. So we got tan 60 is equal to the opposite, which is still 900, over the adjacent. Okay, now we, w. Now we have one variable we can solve for that. That's that same pattern. Do you remember the pattern now?
Yeah.
What is it?
So then you divide by
So it's 900 divided by
tan
60, which is, somebody do it for me. And you don't have to have the pattern memorized.
519.8.
So it doesn't give us much joy because it's, what is it?
519.6. So it's 520.
Yeah, because it says to round to integers.
Okay, so 520. So W is 520. Does that help us?
Yeah, 'cause
Yes.
now you can do it, and then you can do 100. You can do 520 plus z. So tan 42 equals 900.
Well, we gotta still, this is a more uglier, I'm gonna erase this part. We're gonna do some uglier algebra because we don't have a nice friendly number in the denominator, right? We have, what was it, W? 520? Okay. So what do we gotta multiply both sides by?
Z plus 520.
This ain't nice. This one's not nice at all, right? Maybe is there any better way of doing this? There is with sine cosine, but
You
not
could
with it.
do the Pythagorean theorem on the triangle with the right.
Well, yeah, and we could find that.
and
That's,
then find that.
but the problem is this, that would work,
If that was a right angle.
but this, the triangle on the left is not right triangle. So that will get us that side, absolutely. Doesn't get us where we need to go.
So wait, so does sine, cosine, and tangent only work for right triangles?
Yes. Well, for this year, there are other trig ratios and functions that can be used on any triangle, and we're not doing them. But if you're curious, look up double angle and the law of sines and the law of cosines, and enjoy. And those will work on any triangle. Okay, so in this one, we got to stick with that ugly mess right there. And this is ugly because we're going to multiply both sides by,
Z plus 520.
we're going to get distributive property
So
on
it's
this side.
42z plus 520. tan
So we get
42.
z, what is it, tan 42, plus
520 tan 42.
520 tan 42. Okay, that's not too bad. We can actually type that in the calculator, and that equals 900. Okay, that's just a lot of math. We can do that, and that's going to give us literally a number,
468.2.
468.2. Now, if you start rounding, you just got all this error that starts getting introduced. So if you can, don't round until the very end. Subtract that from 900.
Okay, 900 431.79889.
One more time.
431.789,897.
Divide that by tan 42, and we're done. That one took a lot. And that's what z is. And we'll see how close we came to the book answer.
479.55126333.
And the book says the answer is?
479.551263.
No, it says rounding this whole number.
So 480.
And that's what the book says the answer is. So, hey, we got it. So 18 was definitely challenging. Not impossible, but challenging.
So 17 was just done exactly.
I assume that 17 is done similarly. The nice thing about 17 is, look at it. What kind of triangle is it?
It's right there at the 45.
So therefore, it's isosceles.
So W.
So W is 160, right from the start. But you know, half the time you don't recognize that stuff, and then you feel like an idiot, like, oh, why didn't I see that? But
Z is the hard part though.
I'm used to being upset myself at the very end. All right, here we go. Number 1 is 13.7. Number 2 is 23.6. Number 3 is 48.3.
Wait, what?
48.3. Number 4 is 1.4. Number 5 is 55.4. 6 is 3.3. Now, for some reason, they don't have you round in nearest tenth. Now you round in nearest whole number. Number 7 is 57 degrees. Number 8 is 28 degrees. Number 9 is 27 degrees. Number 10 is 37 degrees. Number 11 is 31 degrees. Number 12 is 56 degrees. Okay, 13. W is 60. Is that degrees or is that just not length? And Z is 54. 14. W is 286. Z is 571. 15. W is 75. Z is 89. 16. W is 82. Z is 154. 17, we already said W is 160, Z is 117. And the last one, Z was at 480 and W was 520. Oh wait, we saw both of them. All right, that's all she wrote. I'm teaching you nothing today, literally nothing. You just apply sine and cosine to what we just did.
Yay.
So yeah, I will teach you the class, but I'm saying in big picture, all you got to do now is learn what those two ratios are. But the actual mechanics of what we're going to do today are no different. Tomorrow we will learn one application. It's a useful in some sense application. Every math book uses this. I don't know why this one over other ones. I would much rather us do something with this, like, I don't know, sometimes we'll go out, we'll measure Pikes Peak, like how tall is Pikes Peak from where we're standing. And we can do that without actually walking to Pikes Peak and measuring it. You can confirm what our calculations show, right? The only issue with Pikes Peak is that the further you go away, the curvature of the earth has impact. So it's not, you have to understand that the curvature of Earth affects it some way. But we could measure. So like a lot of math teachers will say something like, how tall is the building we're in? All right. We could measure it with just a protractor and a little bit of trig, right? And a lot of math teachers have to do something like that. And that's what the basic application is. All right, here's your homework for tonight. It looks just like the one last night, except that it's got sine and cosine. You are free to use any one of the three trig ratios at this point. You don't have to use tan or sine or cos. You can use any one that works.
Go back to last year vintage and do my homework on your feet.
And how many people got these questions on the test last week? Like set up, and if the ones that I looked at didn't even have you solve anything. We just set up the ratio. It was like tan theta is equal to what? And it just said, like 3/5, and obviously if you had had this class, you would have gotten that right. And you will the next time you take the test, but you certainly don't get it right. I will say what we're about to learn sticks with you. A lot of like I was telling Jack, the thing when I said, hey, look up the law of sines, cosines, doesn't necessarily stick with you too much, but this one sticks with you. And I don't want to say it's the most useful one, but it's pretty darn close. All right, here we go. What day do you not do math in my class?
Saturday.
If you're in class Saturday.
Tuesday.
All right, last class we learned about trigonometry. Trig meaning triangle, metry or nometry means to measure. So we're measuring triangles. Why triangles get all the love is because you can take any shape, flat, and fill it full of triangles. Even circles can be filled full of triangles. Lastly, or secondly, I said the trig that I'm teaching you right now applies only to right triangles. Now, there's other trig that applies to all triangles, but this one only applies to right triangles. So you have to get a right triangle. And if you don't get a right triangle, guess what?
Can't do it.
You make a right triangle.
Okay.
So any triangle, you can always make it into two right triangles, right? And I shouldn't say any, because if you had a scaling obtuse, right? Well, you can create two right triangles with that thing. Drop an altitude straight down, and you got a right triangle that will help you solve at least a couple of the sides. And that was kind of like those last two that we saw. But the point being is that for the trig that I'm teaching right now, you must use right triangles. And the way you label right triangles for this trig is that you have a hypotenuse that never changes, and you have two sides called an opposite and adjacent, depending upon which angle you're talking about. So McKinley, where is the opposite side to angle A?
B.
B is an angle.
Oh, not B.
What's the side up there that's
BC.
opposite? BC is the opposite. Where's the adjacent?
CA.
You want to bet money?
No, I don't want to bet nothing. AB,
Why AB and not CA?
because that's the hypotenuse.
That's the hypotenuse. Okay.
I was gonna figure it out.
Well, you did. All I'd do is say you want to bet money on it. Now this changes, and this was Anna's question. Because of the first ones on the homework last night, they gave you both angles, and she came to me saying, well, which one do I use? And I said, whichever one you want to use. You will certainly, when you set it up, have different sides depending upon the different angles, but it turns out you get the same answer, which is kind of a remarkable idea. And I'll prove that to you today as well, too. All right, so that's the basic setup. If you can do that, you can do all the three trig ratios that we'll learn in the last two sections. Okay, tangent is the one that we learned yesterday. That's the ratio of the opposite side to the adjacent side. And then today we get the other two that are literally on your calculator. Oh, by the way, there's a total of 6 of these. You're only learning 3 of them. I'll show you the other 3 because you're in honors here in a second. All right, so today we're going to learn the other 2. The first one is called
Cosine. Sine and cosine.
sine. No, I don't know why sine comes first and then cosine. But I do know where the word sine comes from. Okay, the word sine is an accident. It's a mistake. It's an honest to God math mistake. So here's the story. So sine, cosine. Here's the story. So the word sine, S-I-N-E, yes, it's abbreviated sin. Originally, the Indians came up with it. We're talking about the country India. And their language is Sanskrit, or how they're writing is Sanskrit. So originally, their word that they use for what we say sine is half chord. This word right here, half chord, right? And that's because it's done with a radius, and the radius is half of a chord, right? So this is the word in Sanskrit for half a chord, and they got kind of lazy and they just call it chord, right? Here's half, here's chord, so they just say chord. So the Middle Ages happened, right? The Dark Ages, so to speak, and so it gets translated into Arabic because, you know, Rome burns, they're losing all their text, right? So it gets translated into Arabic because it's pretty good knowledge. When it gets translated into Arabic, the word chord, right, turns into J-I-B-A, right? And like lots of languages, ourselves included, a lot of times we like to take words and we'll have to say, I don't know, there's ASAP, you know, an acronym, or we just shorten a word, right? Well, the Arabs did that, and they shortened Jibba, I don't know if I'm pronouncing that right, to just JB. Okay, so the Dark Ages start coming to an end, and all the smart people like, well, all the books survived were in Arabic. Now we got to translate them back into Latin. So some knucklehead, who probably wasn't a math person, right, looks at this and says JB. They read it as literally J-A-I-B, because I guess that sounds the way this is spoken, something like that. Well, in Latin, right, this word in Arabic means bay or inlet. So when they translated the Arabic, which had been translated from Sanskrit, it's translated back into Latin. We don't even know what the original Latin word is because it got lost to history. They use the word bay or inlet. And the word, I'm not a Latin speaker, but that is sinus. I'm not even sure if pronouncing that right. I think I am. So it's a mistake. The reason why we call it sine is a mistake. The word cosine is the complement of sine, so that's why it's called cosine. So sine is a mistake. The word sine, the math is not a mistake. Remember where all these ratios come from? They come from the fact that when you have similar triangles, these are the triangles I showed you yesterday. So if you have two right triangles where one of the angles is 35 and the two angles are similar because of the angle-angle postulate, therefore, as a result of them being similar, we can write their sides in a ratio. What was the ratio we used yesterday? Opposite over adjacent. That's why we had A over B equals D over E. Well, there's two other ratios there, depending upon how we want to arrange the letters. So today's arrangement is going to be B over C or A over C. And if I choose B over C over here, that would give me. So it doesn't matter. As long as you have a right triangle with an angle of 35, we already know the answer. It's in that table, because for all right triangles with an angle length or angle measurement of 35, it's always going to be, okay, now let's put words. B over C or E over F as compared to 35 is the, what's the word we use for E? Over the, and that's what cosine is. Okay. Sine is going to be the opposite over the hypotenuse. All right, so we just need to write these down now. So the cool thing is that the math doesn't change from tangent. It's still the same math, but the ratio is different. So for sine, if it needs to go in the book of truth, put it in the book of truth. It doesn't matter. I didn't hand you a sheet, did I? Sorry. I'll just say this. Most kids remember this. It's pretty memorable, just like the Pythagorean theorem is memorable. But it wouldn't hurt to put in your book of truth. I'll let you figure out where you want to put it. So sine is going to be the ratio of the opposite side divided by the hypotenuse. The cool thing is, like I said, the math, the actual question is just going to have you do exactly what you did last night. Now you just have three options. You can use sine, cosine, tangent, depending upon what information you're given. So that's sine.
I hate it when movies have advertisements.
You hate what?
What? Advertisements.
Yeah, just be lucky they're not on your calculator yet. I'm sure that day is coming.
Let's check them out. Wrong. Oh, wrong.
McKinley, got it written down?
Yes, I have.
Okay, so what's cosine going to mean, McKinley?
Cosine is hypotenuse over opposite.
Wouldn't that make sense? It's not.
Oh.
There is a trig ratio of that. I'll tell you about here in a second. But cosine is, this is on freeze. Cosine is this one. Adjacent over hypotenuse.
Whose bright idea was that? Nucleid. Euclid.
Don't go back to Greece. They would murder you for your pronunciation.
Hey, I can do it. Well, in Greece, I would be seen as a barbarian and kicked out. So,
I don't know. Maybe they make a statue of you.
For saying Euclid.
well, I'll bring my phone back and they'll think I'm a god. So, you know.
That would probably be true. But then again, they may murder you.
No. Then I think you're a witch.
Why would I be a witch? I don't.
Wizard.
Wizard,
Yeah.
that's what I would be. If Anna and Allie went back over the phone, then they would probably be seen as witches.
Apparently, McKinley already sees me as a witch, according to this morning.
Yeah, you are. You admitted to it. Oh, that was Anna who admitted to that. Well,
That was in 7th grade.
whoa.
You're doing a time dilation there, McKinley.
Wait, what? You admitted to being a witch?
You wouldn't stop bothering me, so I just said yes, and you stopped asking.
All right, so we got tangent, sine, cosine. How are we going to remember these things? How are we going to remember these three things?
Cos is the opposite of sine because it's like cos sine. And then like tangent is because like I remember like tangent's the difference.
Do you know how your parents remember this?
Oh, SOHCAHTOA.
Close. What they do, and what you will do too, because how everyone remembers it, they simply take the first letter out of everything and they make a saying out of it. So this says SOHCAHTOA, and it makes that right there. So ka
That's what I said.
CAH, because you'll forget where the A goes. Right. So ka, you won't forget the toa, that makes sense. But you'll forget which one has the A, the so, or the ka. So if you pronounce it, make an emphasis on the ka, you won't forget that it's the cosine that gets the adjacent.
Or say so.
Or so. Ka.
I am so bored of fish.
All right. So this is the saying. When I was in high school, my math teacher made a racist statement about, and she did like she's an Indian and went, ooh, SOHCAHTOA, and she danced around in a circle. And it was very memorable. I remember it because of that, but I will not do that. But I will mention that back then that was appropriate, and no one said anything or thought anything of it other than it was silly. But it's kind of great.
Yes.
All right. SOHCAHTOA.
Jack, you need to stop. You're gonna overwork yourself.
All right, McKinley, chill.
Yes.
Now I promise you, since you're advanced, there's actually 3 more of these. If you take any one of these and you flip it, right? Well, instead of sine, you get the hypotenuse over the opposite. There's a name for it. Boy, I wish these names would match the letters. One of them has a C in it, or it starts with a C. Guess which one it goes with? Not the one that has the C in it. This one is called, if you do the opposite of this, is called secant. This one is called, take a guess. Cosecant. And this one is called cotangent. Cotangent. And I only say this because I'm not 100% sure if it's on your calculator or not.
That makes sense.
You might see it. Where's my
I
calculator?
don't see it. Hold up.
It should be, if it's anywhere under the math button. If
What are you
it's there
looking
at all.
for?
Secant, cosecant, and cotangent. And they'll be abbreviated CSC, COT, and SEC.
Wait, what is COSH?
Well, okay, remember when I said that that's Kosh is what it's called.
Yes, I can read.
Yeah, remember I said there's lots of trig? That's more trig than we want to get into right now.
What does it mean?
It's a hyperbolic function. And we will talk about that in pre-calculus, but not today. But anyway, just in case you see the word cosecant, secant, cotangent, all that is this flipped over.
Oh, I think you're using the wrong thing.
Okay, so we'll start with Anna. This says find sine A. Well, here's A. So what's the right? I'm looking for numbers now. So you look at SOHCAHTOA, or you can think about this yourself. What's sine A?
4/5.
Because sine asks us to do opposite over hypotenuse.
So 3/5.
See what I mean? So maybe having this in front of you kind of helps. All right, McKinley, sine C.
4/3. No, 4. Yeah. No,
Says
4.
opposite over the hypotenuse. So there's C.
Oh, sorry. We're doing C. Oh, all right. Then that's 3/5.
Where's C?
Oh, wait, no, not 3/5. Dang it. 4/5.
It is 4/5. All right, Jack, cosine A.
Cosine A. What do you? Oh, we're going for A, so that would be 4/5.
That would be 4/5. Cosine C.
3/5.
All right, back to Anna, tan A.
3/4.
And lastly, McKinley, tan C.
4/3.
All right, questions?
So
I do the math.
Okay.
And now you can see why these are called complements, or I should say
Yeah.
one is a complement of the other one, right? All right, so box number, whatever else, 4, just do those real quick. Yeah, box 4.
much anger, so much hate.
Ben, you tracking?
Use it.
Yeah.
Let me see if I can find secant, cosecant. Is it on the calculator? On my more expensive calculator, I know exactly where it is, but
I have
I
the
don't
same
know if
one
that
as you.
TI-84 is on it.
I have the same one as you.
I have a TI-89. That's the,
Whoa,
Best.
TI-89.
and it's actually quite old. It's not color. I like this one because the screen's way better.
That's cool. I like mine better. I like the color.
It does not have cosecant. I mean, I know why it doesn't. I'll explain to you in pre-calculus, but
Why does it not
sine is equals,
cosecant. Equals cosecant, right? No, secant.
and that would equal, I should say, secant is equal to
Sine.
1 over cosine. They're just reciprocals
Oh, so
of each
it's
other.
just-
So you have a reciprocal button. But some calculators will have that button.
They're reciprocal.
And you will see as you get to pre-calc that there are lots of trig functions that talk about secant, cosecant, cotangent. I told you the other day, my daughter made fun of me because I didn't know the calculus, and she goes, "Dad, it's cotangent squared, blah, 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 blah." And I was like, "Yeah, okay, smarty pants. You're in calculus, I'm not."
You don't have this.
I know, and if you don't use it all the time, you will forget it, especially the trig functions,
Why would you forget
There's
calculus?
no.
because you just don't use it enough.
there's
all
no-
right, Who do we leave off on? Jack,
What?
sine A.
Oh, sine A equals 6 over 10.
Should we reduce?
No.
Could we reduce?
Yes.
Well, you get the same answer if you reduce.
Yes.
That's true. Okay. Sine C,
8 over 10.
and that would be the same thing. Should you reduce? I would say, yeah, always reduce. But you don't have to. You will get the same answer. Go,
8 over 10.
Gillen.
10 over 8? No, that's not right.
These are not right triangles.
It looks like right triangle.
No, you're interrupting the class there.
Oh wait, 8 over 10.
Cosine is
Six,
adjacent
six,
over
yeah.
hypotenuse.
6 over 10.
6 over 10. Jack.
Oh, tan A equals 6 over 8.
And last but not least,
8 over 6.
and if you had been paying any attention, some of these are pretty easy to figure out. Okay. Why are these not reciprocals, but these are?
Because you don't switch it around. You use
What do
two
you mean?
different variables for. So you always use the hypotenuse, and you use two different things for. the
Notice
denominator.
both of these deal with opposite and adjacent. Although both of these deal with hypotenuse, one deals with opposite, one deals with adjacent. Okay. All right. So math with trig ratios. Remember, we were either solving for a side. When you're solving for a side, I'm not solving right here. It will look something like this when you plug everything. You will have one x. The x will either be on the top, numerator, or the denominator. You do a little bit of algebra, and away you go. When you're solving for an angle, though, what's it going to look like? And it's going to have one little difference in what it looks like. It's not going to say sine, cosine, tangent. It's going to say inverse sine, cosine, tangent. Okay. I will show you the algebra one time behind it, and then universally, no one does the algebra. They just realize that the inverse of sine, cosine, tangent gets rid of the word sine, cosine, tangent. Okay. So solving for a side. Okay. If one of these was missing, say the 3, right, and I made that an x, right, then it would look like that. Okay. If I were doing it, well, okay, this is kind of dumb, but if I were doing it for cosine, right, and the 4 was missing, okay, this is kind of more for the regular class, not for you guys. For the tangent, if the 3 was missing, the setup would, I'm not sure what it says cosine, it should say tangent, would look something like that. For an angle, the only true difference is that instead of saying sine, cosine, tangent, it's going to say inverse. Now, here is the math behind it. To solve for the A, to get rid of the word sine, you do the inverse sine to both sides. So the shortcut method is simply inverse sine of that specific ratio, and that will solve for A. And I make the same mistake twice on the second step, or third step. Nope, that one's right. And the last one, does it say tangent? It doesn't, it says cosine. So 2 mistakes. What do you know? Okay, how come I didn't catch that period 1? Don't know. So solving for a side, recall from last class, if we're solving for a side, yesterday we only knew, now we know everything. So on this one, well, it's only got 2 things listed, and it's the opposite and the adjacent, so we do want to use tan. So tan 56 would equal to y over 32. We multiply both sides by 32, and the pattern for when the variable is in the numerator is the denominator times the tan of whatever angle that is. Why? Because of the algebra right here. When you reduce, you're left with 32 times tan 56, and that's what y would be. Right? We did that one yesterday. The ugly one is when the variable is on the bottom. If you remember, the pattern is 14 divided by tan 15. But if you want to see y, we multiply both sides by x. On the right side, the x's cancel. Divide both sides by tan 15. And like I said, the pattern is numerator divided by tan, whatever the angle is. And that's what x will be. Okay. Lastly, what will the problems look like today? Well, they're going to give you lots of things. And you have 3 options. According to box 5, what are we solving for? And x is a side or an angle. And boy, will they look, they're using a lowercase letter to indicate a side. And they'll use the same lowercase letter to indicate an angle. So just be careful, don't always assume. I wish they were a little bit more, I don't know, better with their how they're labeling things. But most math books do this as well too. Okay. All right. So the side is x. So McKinley, if I'm solving for x, tell me what information up here I know.
The hypotenuse.
I know the hypotenuse, and I know the
tan or sin, the angle.
and I know the angle. So I know those 2 things. So I know the angle, and McKinley said I know the hypotenuse, and x is the opposite. So thinking of the 3 trig ratios, which one involves the opposite and the hypotenuse?
Sin.
So sine is what I'm going to use. So this is kind of the process you need to do in your head. Figure out what you have, right, and which one does it match. Okay, so McKinley, what am I going to write?
60, sin 67.
Let's say sine.
Oh, sine 67 equals 120 over x.
Because it's
x over 120.
Okay. Now what?
Then you multiply 120.
Both sides by 120. Okay.
And you get your answer.
All right, so do it.
Okay.
This is box 5.
I got 110.46, which you can multiply, round up to 110.5.
Does that make sense given the numbers that are up there?
Yes,
Why?
because it's smaller than 1.
Smaller than the hypotenuse, and it's not 11, right?
Yeah.
Clearly, if the hypotenuse is 120 and this is the longer side, you got to get a reasonable answer at 100. What is it, 111, you say?
No, 110.
110? Yeah, that's a pretty reasonable answer. All right. Anna, I got to solve for y now. Tell me what I got.
You can, since you know x now, then you can use.
So we got lots of options, right? Since we know x is 110.5, we could use, right? And I'm not saying this would be a bad choice. It's fine. With a calculator, it doesn't make a difference. But if you really don't want to be as accurate as you want to be, use the numbers that are given, not the numbers you calculate, because you're always going to be rounding. So if I force you to use 120, which trig ratio would that be? That would be cosine. Now, if you used x, what would it be? X being 110.5. It would be tangent. And you could, nothing wrong. I would never count you wrong on a test or anything like that. But I probably would use the 120 because it's not a rounded number. So we throw that into cosine, adjacent over the hypotenuse. Is this the, yep, this is another one of those easy ones. So what are we going to do? Both sides. 120s cancel. Remember, get 47. Okay, cool. So that's solving for a side, yes? I mean, the only way they make this uglier is that they just give you a shape that you need to count up pieces, parts like the last one, 15 and 16 were. And we'll do one of those at the end here. All right, solving for an angle. Remember that when we solve for it, we need to get rid of the word tan. The way you get rid of tan is by doing inverse. No one actually writes this out. They only write what's to the right of the equal sign. But that algebraically is what must be done to get rid of the word tan. You do inverse tan. Okay. So really, this boils down to inverse tans of 1, which is 45 degrees. All right. So McKinley, what do we got here?
Stuff.
What sides do we have here?
Opposites and hypotenuse.
So which am I going to use?
You're going to use sin.
Sine.
And,
I never should have said sin because it's going to stick in his brain the rest of the year.
N equals 22 over 40.
Sine of n equals
22 over 40.
Okay, and then to get rid of the word sine, we do the inverse sine
All right.
of the same ratio. So what's the answer? Calculate. Notice I'm very lazy. I'm not writing out the algebra because no one does it.
33.54.
Okay.
That's me rounding.
That's what I got to. All right, you got it. All right. Jack, you call out a angle. It can only be A or B. And you call out a trig function, and the next person has to give you the answer of what it would be. Go.
Okay.
Trig function, or trig ratio. Give me the tan of A. Okay. Now, side, or angle, sorry. Trig function. Cosine of B. No, McKinley. Just tell me the ratio.
Cosine B, 3 over, no wait, 5 over 4, no, 4 over 5.
She's throwing them all out.
What? That's right.
Cosine is what?
It's adjacent over hypotenuse.
So we're at B.
That's 4.
That's
No,
not 4.
No, that's 3 over 5.
3 over 5. So just be careful with it. Okay, enough of that. So here's the challenging problem, the last one we do. It says, take that one triangle and calculate all the altitudes. So if I were to draw the altitudes, watch me. There's one altitude, there's one altitude, and there's one altitude. What do you know about these two altitudes? So this is isosceles triangle.
There's
No, these two right here.
what do you mean?
Since these two sides are A,
They're the exact same.
what would be the difference between the middle one and the right one?
There is no difference.
There is no difference. So all we need to do is calculate two of them. All right. So first one. Quicker. There we go. Make that altitude. Hey, it's an isosceles triangle. So what do you know about when you drop an altitude from the vertex of the angle formed by the two congruent sides? That angle is 90. That angle is
90.
It's an isosceles triangle, so this angle and this angle are so similar or congruent because of reflex. So hypotenuse leg. Therefore, they are congruent, or they're similar. Either one's fine. Therefore, they're cut in half. So therefore, this side is, and this side is. Okay. If I'm solving for the red portion, Jack, pay attention. They got two sides. You can use trig if you want, but we got to calculate a degree angle first to use trig. But if you have two sides of any right triangle, you can always, this was 16/7 or 16/18, we used Pythagorean theorem to get the third side. So I could get that red side right here, altitude, just by using Pythagorean theorem. So 3 squared, 9, 8 squared, 64. 64 minus 9 is? So therefore B is, we're not done, we gotta finish this one. This is a hard one. All right, here we go. So B is 7.4, we're done with that one. Now we gotta do this one. Remember, this won't be exactly the same, just on the other side. Okay. We got a problem. What do we know now on this triangle? What do we know? And we saw this one's 7.4, and this piece is 3. So what do we know on this triangle?
One side.
We know one side. That gets us nowhere unless it's a special right triangle. And we don't know if it's a special right triangle. So we got problems. 9 times out of 10, when you have problems with right triangles, guess what you do? You call on your buddy, Mr. Trig, to help your butt. So that's what we're going to do. We're going to call on Trig. In order to do trig, we either need 2 sides and not an angle, or we need an angle and 1 side. I only got 1 side. That means I have to have an angle if I want trig to help me out. Okay, 90, that doesn't help me. I either need this angle or this angle. You're like, well, I don't have any angle.
Oh, you can figure it out from the past one.
We can go back to the previous one. We said this side was 3, so this side is
3.
okay. And this angle are
Exactly.
they're the same. It's the same triangle, right? So if I call that theta, and we know that this piece right down here is 3, then I have 2 sides and an unknown angle. I can use one of the trigs. What do I know? This is cosine, adjacent hypotenuse.
68.
What is it?
67.9.
So about 68 degrees, right? So I know this angle is now 68 degrees. Now I've got 1 side and an angle. I can calculate the 3rd side. So what's the this is a little bit harder. What's the trick? Looking at it, what's the trig function?
It's going to be either sine or cosine.
No, we want the red.
No, it's cosine.
We want the red.
Sine. It's sine.
Why is it sine, not cosine?
Because 6 is the hypotenuse and 68
It's the hypotenuse,
is opposite from the
and that's the opposite side. So we want sine. So sine of opposite is x. Oh, it's the nice one. Over the hypotenuse, so it's 6 sine 68, which is,
Oh, I don't want to do that. But
well, it's just a calculator drill.
I know. It's okay.
Does that seem reasonable as an answer? 3.7?
Yeah.
An unreasonable answer would be 37, right? For the red. Okay. And I got 5.6. There's definitely a mistake on one of us.
Yeah, I got 5.
So now, when you make a mistake, what you should do, don't clear anything, hit your up arrow, and just scroll up. You did 6 sine 38,
Oh,
it's 68. So never discount fat fingers. They will let you down. And that's why whenever I do anything with calculator, I'm going to do it twice, and I'm probably going to pause and not look at it. All right, that's it. Ben, any questions?
I wish I had that.
No questions.
Make sense?
You want to write it down?
Yes.
Yeah.
Cool. Ben, are you contemplating coming back to school at all for the rest of the year?
Maybe. I'm not 100% sure.
Just curious, no reason.
Extra boy in my class.
That'd be nice. I've never outnumbered girls.
Well, you better enjoy it while it lasts, because next year it ain't going to be that way. Next year it's going to be nothing but girls answering questions.
They're gonna be coming back next year.
Oh, wow.
I can out-answer all of them.
I out answered everybody. last
Correctly?
year. I was like, what
No,
am I-
not correctly, but I can.
Well, right now, unless you up your game, then you're still not top dog, because Anna got a higher score than you got on the test.
She did?
Yeah, I told you that.
Anna Sawyer?
Anna Sawyer got a higher score than you on NWEA.
Uh-oh.
That's okay.
But they're
This
within
is TI 84
2
plus
points. No, I know that one, but my one at home is a TI 89. Oh, no, I have it right here. Don't I? Somewhere. Where's my good calculator?
Whoa.
This one does calculus on it.
It's also dead.
Yeah, I don't turn on much.
What the heck does that button do?
Which one? The alpha? Oh,
Oh, that's just alpha.
no, the green one?
Yeah.
Well, there's just other functions there that does. So there's lots of other things. So notice this one has 2 colors. This one has 3 colors. So you got
Oh.
sine, inverse sine, and a Y next to it. So that's just the 3rd color.
Oh.
This is what the calculator took me through college. I need a new one. It's starting to fade. The Inspire also is pretty sweet, but you can't use the Inspire on SAT. What's up? Your homework is a worksheet.
I think we did.
No, it wasn't a worksheet.
Bye, Mr. C. Have a nice day.
Oh, I'm sorry, Ben. Left you hanging there. See you later.
It's fine. Have a nice day.
You too.